Today let's be solve the NEP Physics first semester PSc degree examination February 2023. So this is the paper 1 mechanics and properties of matter. So as we move further, let's we see some problems. The first problem is, this is the question paper. In section B, they ask answer any 5 questions. Out of 8 questions, you must answer only 5 questions. Each carries 4 marks. Let's begin section B. The first question is, the initial mass of a rocket is 100 kg and the final mass after the fuel burnt out is 10 kg. If the velocity of exhaust vapor velocity exhaust velocity relative to the rocket is 2 km per second, find the maximum speed attained by the rocket. And this question is related to the final velocity of a rocket. So let's see who can be solve this one. So this is the given. Assume that the initial mass is velocity of the initial of the rocket is 0. Then the rest mass is 100 kg, which includes fuel also, and after final mass is reduces to only 10 kg with exhausting velocity 2 km per second. So as we see that, we see the formula for escape velocity is V initial velocity plus escape velocity, maybe a negative, so it's a negative. So then log of me by m naught by m. So v naught is usually 0, so escape velocity is 2 log of to the base e 10 to the power of 10. Then we solve it, you got the value of log 10 to the power of 10, that's log 10, but it convert to log 10 base from e to log 10 base, that's why it is multiplied by 2.303 by factor. So if you multiply, then you got the final velocity is 4.606 km per second. This is the way we calculate the final velocity of the rocket. So see the next second question. A body of mass 2 kg is moving with the velocity of 10 meter per second collide with another body of mass 6 kg moving in opposite direction with velocity of 20 meter per second. During the collision, they stick together and find the common velocity. So there are the two bodies is there. One is 2 kg moving with the velocity of 2 kg ಇದೆ, 10 meter per second ಮೂವ್ ಆಗ್ತಾ ಇದೆ. There is another body is 6 kg moves in opposite direction, there is 20 meter per second velocity. So then they collide both. This small flash is cling to this body. So find the common velocity of that body. So let's see this one. m1 is the 2 kg and its moving with the velocity is u1 10 meter per second, m2 is 6 kg and moving with the velocity of minus 20 meter per second, and they click to the last one, that is the final velocity v1 is equal to v2, that is equal to u. So as we know that from the collision between the two particles, we see the formula m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Here initial m1 v1 m2 u2, but after they collides the two body cling together, that's their cling together means m1 is mass and have common velocity is v. We find the common velocity v is equal to m1 u1 m2 u2 divided by m1 plus m2. Put these values, then you got the value v is equal to 10 minus, because minus here is the body is moving in opposite direction, the 6 kg wall is moving in the opposite direction, that's why it is minus 20. So there is minus 26 into 20, so 2 plus 6 is the mass of the body, so that gives the value of minus 12.5 meter per second. Negative means moving in opposite direction. So see the question number 4th. A system consists of a masses 5 kg and 10 kg. There are the two masses 5 kg and 10 kg. They are located at 2, 5, 3 minus 3 and 2, 5, 6, the 10 kg one respectively. Find the position of the center mass. As we know that center mass whose mass is appears to be consolidated in a single point. So let if the mass is m1 5 kg, m2 is 10 kg, given that taken in a position vector, that is 2i 5j minus 3k, ij unit vector taken the unit vector, r2 2i 5j plus rk. We know that the position vector formula caps mr is equal to sigma mi r1 plus m2 r2. Here is only two body particle, that's why we take r1 and r2 m1 for m1 and m2. That's why formula is r is equal to m1 r1 plus m2 r2 divided by m1 plus m2. Put these values, then you get the 5 into 2i, the point distribution, 10 into this one, and mass as 5 plus 10 1. So after 5 into 10 10 10i, this 10 into 20 20i, that gives the 30i, 5 into 5 25, 10 into 5 50, 50 plus 25 75, 75, and last one minus 15k 60k minus 15, if you remove this 60, that is 45k divided by 15. So that's the value is 2i, 15 is 2, 15 5s are 15 3s are, let's say 2i 5j 3k will be valued, that's you got 2 5 2i plus 5j plus 3k value can be get. And see the fifth question. Fifth question is related to artificial satellite launching. This artificial satellite revolves around the earth close to the surface, calculates its period of revolution. Given condition is radius is given and g is given. Say artificial satellites revolve around the earth, you calculate the period of the revolution. You calculate period t can be calculated by using the formula. That is, radius is given 6.4 10 to the power of 3 kilometer. Just kilometer is 10 to the power of 3, that's why it is again 10 to the power of 6. 6.4 into 10 to the power of 6 meter. The acceleration due to gravity is 9.8 meter per square. You calculate for the period of revolution of the satellite is given by t equal to 2 pi into square root of r by g. Put this value to constant pi 3.142, radius value 6.4 into 10 to the power of 6, because it is in kilometer we must change into meter, and g value is 9.8. so after you get the 5078678 seconds, and you got the divided by 60 into 3600 seconds, then you got the converted into hours. This is the period of revolution is 1.411 hours. So let us check the next problem 6. Calculate the Young modulus of the material. You must calculate the Young modulus Y. So the given is the material of wire of 3 meter long, 1 mm radius, 1 millimeter radius is there. So then when the force is 950 Newton, increases to its length is 5 mm. So how can we calculate the Young's modulus? We know that length of wire is 3 meter, radius is 1 mm, means 10 to the power of minus 3 meter, force is 950 Newton, and change when the force is applied 950 Newton, there is a change in length is 5 into 10 to the power of minus 3. So this gives the given content. We find the Young's modulus, that is Young's modulus is equal to stress divided by strain. What is stress? Stress is force per area, and strain is change in length to the original length. Put this value and simplify, that is the L will come to upper side, and F cross L divided by A cross dl. F, we know that the value is F is 950, L is 3 meter, and pi r square, pi radius is 1 into 10 to the power minus square into delta L. Delta L means change in length when you force it applied, that is 5 mm, that is 5 into 10 to the power of minus 3. So after solve this value, so we will be get the 18.2 into 10 to the power of 10 Newton per meter square, the Young modulus of that wire. Let us see the 7th one. How much work is required? Twisting a steel wire of radius 10.3 meter, and length of that steel wire is 0.5 meter through an angle of 45 degree. The rigidity modulus of the material of the wire is given by 8 into 10 to the power of 10. The rigidity modulus is given, length of the wire is given, angle is given, so radius of the steel wire is given. So calculate the how much work is required to twisting. How can you twist it? How much of work is applied to the wire? Let us see. At first we see the given one, the radius A is 10 to the power of minus 3 meter mm. So length is 0.5 meter, that is 50 centimeter, or 0.5 meter. So the rigidity modulus is 8 into 10 to the power of 10. So the angle we twisted is 45 degree. So 45 degree is converted into radian. So 1 degree radian is 5 by 180. So 45 degree is 45 into pi divided by 180. That gives the pi for radian. That is pi for radian will be the theta. So for the calculations of the work, we have W is equal to half C theta square. C is the coupling. So coupling can be given by the relation. The C is half C can be given by pi into rigidity modulus n area radius a to the power of 4 and 2L. So after equating 1 by 2, pi is 3.14, rigidity modulus is 8 in 10 to the power of minus 3, area is 10 to the power of minus 34, and 2 into 2 is the here, 2 into 2, L is 0.5 meter into theta square, that is pi by 4 whole square. Here is missing, so it was given in the under solve equation. So put this value. So pi by theta, pi means here not 180 degree, it is a 3.142, that is pi 3.142. So you got the value equal to 0.075. So here is the theta is there 3.142 into divided by 1/4 theta whole square, its value gives the value of 0.0775 joule is the work. That's why it is unit is joule. Let's see eighth one. Calculate the pressure inside a drop of mercury of radius 2.5 into 10 to the power of minus 3 meter at room temperature. What is the excess pressure inside the drop? Given the condition is given, the surface tension of the mercury is given, atmospheric pressure is given 1.01 into 10 to the power of minus 5 Newton meter square. So the pressure inside a drop of radius, the drop of the mercury is 2.5 10 to the power of minus 3. So calculate the pressure inside the drop of mercury. So let us see the eighth one. So here total pressure inside the drop is equal to atmospheric pressure plus excess pressure inside, but atmospheric pressure is 1.01 into 10 to the power of 5. The excess pressure is given by the formula 2 into T. T stands for surface tension divided by R. The excess pressure is 2T by R formula plus atmospheric pressure. So equate this value 2 into 4.72, 2.5 into 10 to the power of minus 3. So the answer is 1.01377 into 10 to the power of 5 Newton, 10 to the power of 5 Newton per meter square is the pressure inside the drop. So you see for last one, ninth one. Water flows through a horizontal tube. Water is flows through the horizontal tube of length 0.36 meter, and internal diameter of the tube is internal diameter not radius, diameter 0.2012 10 to the power of minus 2 meter under the constant pressure head of liquid 5.1 10 to the minus 2 meter. If 2.2 10 to the power of minus 6 cubic meter of water issues from the tube in 40 seconds, find the coefficient of viscosity of water. Given density of water is 10 to the power of 3 kg per meter cube and G is 9.80. So from this we can be find the coefficient of viscosity. The coefficient of viscosity is given by the formula this one, pi rho r to the power of 4 8 VL. So here rho is there, so rho equal to pressure is equal to rho into G into H. Rho is 10 to the power of 3, G is given, H height of the tube is given, that the length of the tube is nothing but height of the tube. So volume is 222 into 10 to the power of minus 6 divided by 40, that gives 0.55 into 10 to the power of minus 6. Length of the tube 0.36 meter and radius is 0.1006 into 10 to the power of minus 2. Then putting this equation, equate this pi value, rho value, r value. So after you can get 8 into volume, length, that's the coefficient of viscosity is given by 0.001014 n Siemens per meter squares. So this is the question paper of 2023 February of the physics NEP will be solved. Okay, thank you.